Hello everyone, welcome to today's KubeEdge SIG AI meeting. I'm the host, Shijin Hu. First, let me introduce about KubeEdge SIG AI. KubeEdge SIG AI focuses on AI and edge cloud synergy with two main projects, Sedna and Yanos. Sedna enables edge cloud collaborative AI with support for joint inference and federated learning across major AI frameworks. Yanos provides benchmarking tools and test cases for evaluating and optimizing distributed AI solutions. So today we'll still have two sessions. The first is the international session, and we will have two projects, both from the RFX mentorship project. First is a comprehensive example restoration for Janos by Abhishek. So now Abhishek, you could share your screen.
Yes, sure. So as suggested by, I'm audible, sir?
Yes.
As suggested, as Jimu sir has suggested the changes, I have made all the changes that was suggested in the last meeting, and as we have discussed that I will be mainly working on one example, like focusing mainly on one example, and after that I will be extending that to the all 25 examples if time permits me. And I have changes the goals according to that. Like in this project, we will focus on restoring one example as a proof of concept with restoration of additional examples for future work. And also apart from this, like I have also added like establishing CI/CD pipeline as the primary goal of this project. Apart from this, all the other things that are not related to this, I have kept them in optional goals. Like as suggested by you and Kimu sir, like my main goal should be this. So I have put this in the main goal, and accordingly, I have also like make changes in the architecture. Like there was an error, like here this was another example. Now it has been changed to lifelong learning example, which was suggested in the last meeting. So I have changed this also, and I have also like updated the contributor user flow and also the maintainer user flow accordingly. So I have made all the changes, and everything is up to date. It's just needs your review on this. Audible, sir?
Hello.
Yeah, yes.
Thank you. Um, and it have been quite a long time.
Yeah.
We need to we need to come back and try to follow up the whole proposal. And then I think the first comment from our last meeting would be to update the goals, the scope, and the user flow. And I have saw the updated goal, which is good. And then could you show us the user flow?
Yes. Sir. So this is the user flow. In the user flow, we are having this contributor diagram. This contributor will arrive and access available resources and make changes to the lifelong learning examples. And apart from this, he will submit the request, and like CI/CD pipeline will validate it, and if this will pass, then merge will be successful. Otherwise, it will receive a feedback and debug that issue, and then this will make again the changes to the lifelong learning examples. This is the contributor user flow for KubeEdge Advanced.
Okay.
And apart from this, this is the architecture diagram. Like here was an error. Like it was like written another example, but as you said and we have discussed in the last meeting, I have updated it to the lifelong learning example. And this is the maintainer flow, where there will be a daily, weekly check if like monitoring the lifelong learning example. If there is an issue, fine, then we will analyze the root cause of that issue, apply systematic and restoration methodology, and validate that fixes. And if it's successful, then document that fix. And apart from this, if the fix is not success, then we will analyze the root cause again and apply systematic restoration again and try to fix them and document them.
Although it seems fine. We have
Yes.
already the contributor workflow and the maintainer workflow, and
Yes, sir.
both of them. I think it overall looks fine.
Yes, sir.
As for the maintainer, how could he know how could he monitor the health of the one of the example?
Like we will look for,
maybe he can I don't know, open up the pull requests to take a look at the CI/CD report or something like that.
can you please repeat the thing that we get, sir?
You can open up the workflow for maintainer, and we can discuss a little bit about that. And as we can see, the purple one, right? The lifelong example health status could be monitored, right? My question is, how can the maintainer monitor the status? Will we provide a new tool to the community, or we just, I don't know, open up, let the maintainer open up the pull request and check all the status of the CI/CD results?
Like it can be done by both ways, as you can suggest. So like I will welcome your suggestion on this, like what I should prefer.
So you prefer the first one? Maybe we can provide a tool for a maintainer. I don't know. Or
Okay. I will go by this way, as you have told, sir, like providing a tool for maintainers.
okay, so our maintainer will have a tool, and it also one part of the Janus project, and when he open up the tool, he can monitor the status for our examples. But here is the lifelong learning one. So is that right?
Yes, sir.
Okay. Good. So that would, I think that would lead to actual workload for this project. So do we have any I don't know, plans or the specific program or code space we are prepared to add to implement such a monitoring feature?
Like I have not thought about that yet, but I will like think about it, like how it can be done.
Okay, so my suggestion so far, I think the workload we can see for the whole project is already quite heavy. My suggestion would be maybe in the very first phase, for example, in this LFX program period, maybe we can let the maintainer just take a look at the CI/CD status manually, at present. And then if we have time, we can have some more tools to make the health monitoring more efficient or effective.
Yes.
I think the key of this project would be, first we need to build the CI/CD process. The CI/CD process is the most important one, our most important goals, and then the other tools we can have it maybe later on this program. So
Yeah.
you are also fine with that, right?
Yes. That's why I have in the primary goal I have put like fixing the one example and implementing the CI/CD pipeline, and I am mainly focused on that part for this project.
Okay, great. So I think we are in the same page, and so I'm fine with the first comment. And then for the second comment, we have the architecture figure. Yeah, maybe you can show us again the architecture. So we would like to update the lifelong learning example and also the CI/CD pipeline for Python check. And we will make the test environment manager, test case controller, and story manager unchanged. Okay, so we won't introduce like algorithms, new data sets. That focus on the lifelong learning one. Which lifelong learning example we are going to tackle? I don't know, the cloud robotic one, or
like I will pick any one of them. If you want to suggest any one of them, then I can pick that also. But I will work on any one of them.
Okay. Sijing is also online. Do you have any suggestion if we need to pick one lifelong learning example to for Abhishek to somehow polish? Maybe cloud robotic would be a good idea. I don't know.
Yes, I suggest maybe you could start with the cloud robotics data side, which is it's a polished example for the lifelong learning. I will send the URL of the cloud robotics example of lifelong learning in the chat box.
Okay.
Great.
I will work on this lifelong learning example then.
Okay, thank you, Abhishek. Then I have no more question. I think the whole proposal at present is good enough to merge into our community. And myself, I will give LGTM. And do we have any other comments to Abhishek? Any review on our Sijing, who is also online? Yep.
Yes. Well, the proposal is also looks fine to me, so I will also give the LGTM.
Okay, great. Then congratulations.
Yeah, thank you so much, sir. Like, it's all your guidance, sir.
Thank you for your hard working. We see very comprehensive proposal, and then after all we receive 2 LGTM, we will merge this proposal, and that means you will pass the midterm evaluation of LFS program. Congratulations again.
Thank you so much, sir. Thank you so much.
Great. So maybe I think then that is all for the first topic.
Yes, sir.
And okay, thank you, Abhishek, for coming.
Thank you, sir. Thank you, sir.
Then maybe we can turn to the next topic on our agenda.
Hello, Abhishek. You could stop your screen sharing. Okay. So next project is from Ronak. So Ronak, you could share your screen now.
Hello, everyone.
Hello.
Is my screen visible?
Yes.
Okay, so my project update. Last time, Sizing sir gave me an LGTM and Zimu sir approved the pull request, and the pull request was successfully merged. After that, coming to the real project, how far I have come on it, and what is the update. So by now, according to the phase one, according to the phases I had divided in the roadblock section, I had to collect the URDFs, add meshes to the URDF so that they look realistic, and create the simulation environment. So I have done it by now. So I'm going to run it now and make it a check how it's good or not. So this is the environment I have created. I've created a table, uh, um, attached the motherboard, the robotic arm, and created a panel at the side. On the panel, I have like five components. Fix those five components at a place. Uh, this is the environment I have created. I did not try to make it too hi-fi, because our main concentration is on the desk. So this is it. Did the proper lighting so that the components are visible, and this is it. These are the components. I just added, like last time I asked from Zimu sir, like how many components do I add? And I said like, if is five okay? So he said like five would be okay in the process. So these are five components I have added. Here's the motherboard. I have added the motherboard also, the robot arm, and the environment. So this is the complete setup I have created. My next step would be adding the camera that will be on the robotic arm, and after that, adding the algorithms like YOLO and CNN so that the detection part starts. And I'll be writing the code so that the complete assembly orchestration tables. So this is my project update so far. I request the maintainers to comment on this if this is okay, or if it has any kind of drawback or any kind of issue.
Okay.
Yes, sir.
So, thank you, Rana. And I think that it's fine. And I just want to make sure that I clearly understand all this word. So in the terminal, we show the how this whole assembly process is going. So we loaded the motherboard, and then we install some select CPU, RAM, something, some more than 5 component on it. So the log shows the whole assembly process. Am I right? So in the terminal, it shows all the process that the component assembly program goes. Is that true?
Sir, excuse me, sir. Your voice is quite down. Maybe you're not near the mic.
Now it's now okay. It, could anyone hear
Yes,
me?
sir, it's fine now. It's fine.
Okay. My question is in the terminal we saw some logs, right? And is that means the whole process of the component assembly program goes. So we first load the motherboard and then install some CPU, RAM, something like that. Some more than 5 components. That so the terminal shows all the assembly progress. Is that true?
Yes, sir. Because when I was fixing all the components one by one, I had to add those print statements so that I come to know if any of those is coming to the simulation environment or not.
Okay. So we will use this progress to update the whole simulation environment, and so that we can finally create the whole simulation data set.
Yes, actually, I created another file that was a lab environment file, and that file was just for my purpose so that uh, I add all the components, I position them according to my will, and I can quickly check the simulation after every fixing of the component or even after changing the orientation or position. I could quickly check it. So I created a file. Later on, I'll be transferring this complete file to the file called generate dataset, in which I'll be adding those. I'll be I'll be just making it more responsible, like those pictures, those algorithms. I'll be adding it, and then I'll be generating the final dataset.
Where and then my suggestion would I think the overall whole progress looks good, and we now see the URDF and also the whole logs and your plan, and I think that is good. And then my suggestion would be maybe we can focus on one sub progress. Maybe I don't know, maybe we after we load the motherboard, we are trying to install the CPU slot, and then we try to generate some data. And on the next meeting, maybe we can take a look at the data, and if that goes well, we can get all the things continue to go. And then if we have one data set ready, and I think maybe it is also necessary for us to make the integration as soon as possible. and I mean try to make our developments based on the Janus code space. So once we have our first version tiny data set, we immediately try to have it run on KubeEdge Janus, and then see how the whole process goes, and make a tiny demo for the very first view.
Okay,
So
so
yeah.
okay, so I just need, so as soon as I'm going forward, I need to keep checking the integration of my project KubeEdge Canvas so that the complete code is accommodating with Canvas or not, or maybe it's misbehaving or not. Like I need to do that right at every step.
Yes, exactly. And then we can avoid any accident could happen if we make a super large data set and then put the integration in the final state that could lead to some maybe some delay of our whole project. So it is a very good practice if we try to make the integration as soon as possible. Then we are ready to submit the whole code space anytime during this program. So we are safe for this project. So that is my suggestion, and I think everything goes very well as far as I'm concerned. Thank you, Ronak.
Thank you, sir. Okay, I will do that. That will be my next step to add to integrate Canvas as soon as possible. I was asking whether the size of the components and the size of the motherboard is all right or not, because the motherboard looks quite big. I was thinking whether to make this motherboard big or not, because I can lower the size any time. But my main project was about small components. The components have to be deformable. There was nowhere in my project that the motherboard has to be deformable or very small. So I think the component size is what matters. So is that size okay? Is that size all right? So I just wanted to confirm whether the sizes are not, I mean, proper or not.
In fact, I do not have a off the shelf question right away, off the shelf answer right away. But um, my opinion here, maybe we can have a principle to make the motherboard as realistic as in possible. It is not about the workload, but it is more about how this data set could be used. So my suggestion is that we try to make the final data set looks like the real world object. So the size do matter. So we try to keep the size consistent with the real world motherboard. I wonder whether that is practical for Ronak.
At the first I thought the motherboard is actually bigger than the realistic motherboards. But the thing came to my mind is motherboard could be a television's motherboard. The motherboard could be a laptop's motherboard. Need not necessarily need to be a smartphone's motherboard. So the motherboard size I feel is perfect.
Okay, I think we can also start from some um, um, easier one, maybe laptop or TV motherboard, right? And if we start from a smartphone motherboard, it is also practical, but it could be have higher difficulties when we try to do some assembly job. So we try to
Okay,
hereby
okay.
try to choose a larger motherboard.
Yes.
Yeah, that also goes fine for me. But I wonder whether that could lead to the difficulties of the final testing task. Here, I believe that the final task could be simple, could be easier for the whole process to go through. But when we, for example, we want to test a series of different types of machine learning model, I think maybe our dataset should remain some difficult tasks there, and so that we can really measure which model is better for our whole process. I think that is important. We do not want to see, okay, no matter what the task, the assembly task itself is too easy, and then no matter what model I put, it have a score like 100%. They have a successful score of 100%. So then that could lead to the fairness problem of the whole benchmarking. So I think we should remain a certain extent of difficulties in the whole process. So that is what we need to also keep in mind. That kind of difficulty should be problem that really existed. So it should be the real world enough. Looks like the real world objects enough, and then reasonable difficulties should be existed in our final benchmarking dataset. I don't know, am I make it clear? So I don't want the dataset to be
Yes, sir. Makes sense.
test that too easy. We should remain a little bit some difficult job or remain in the test dataset.
Okay, sir.
Okay. So you believe that the current size of our motherboard right away can also create some difficult testing job for our benchmarking, right?
Yeah, yes.
Okay. Could you explain to us, give us some I don't know, justifications and to let us know the reason about how we suggest such kind of the motherboard.
Yes, sir, you are audible. I did not understand the main question.
Okay. I'm is it now better? Hello?
Yes, sir, it's better. Yeah, yes, sir, it's
Yeah.
better.
Okay. My question is that Ronak believe that when we choose the current size of the motherboard, it is, although it is not the, for example, smartphone motherboard, but it could be laptop or television motherboard. So it is fine. It is realistic enough, and it can also create some difficult test job for our final benchmarking. And my question is, how can we ensure that, or what is our plan to make some kind of typical jobs, typical test job in our test data set. Could that, because we choose a larger motherboard, so the assembly process makes the whole testing job too easy, and then is that
Okay.
possible to make the whole process too easy, and then we, no matter what we are testing, no matter what kind of model we are, machine learning model we are testing, they always getting a high score. And I wonder, do we have any specific measure could be taken that making the final testing job more have some difficulties or challenges samples in the test data set?
Okay, so I got it. So because the size is quite big, so the assembly process is going to be very easy because there is a lot of space and the components can easily be fixed at any place.
Yeah.
Or maybe at a corner, at any corner. So how can I make my data set a little difficult? Because this seems too simple, my data set. Okay. Uh, a good question. Uh, I believe if that is the case, then maybe the size could be site could be made a little small because when I submitted the proposal, when I added the pictures in the proposal, there the motherboard was made a small smartphone size motherboard, uh, which shows precision and accuracy. So if this motherboard goes too big, then the accuracy factor may go missing somewhere. So that makes sense. So I'll look on this part whether that needs to be done so that the data set works according to the proposal. And about whether how to make it more difficult, right now I have no clue in my mind that how can I make this more difficult. Uh, um, I can make
Okay.
the size smaller so that
Mm.
the accuracy factor remains as a matrix.
Okay. So I think that is already good enough. And then for now, it is also consistent with our previous plan on the whole process. We can have some trials. We can make some small data sets and then integrate to Janus as soon as possible, and then we take a look at the performance of our machine learning models. If all machine learning models are getting very high precision score, then maybe we need to make the ball more smaller, and then you can take several trial, and then we can see what kind of difficulties could exist in, and what kind of size we need to generate it, and making the dataset more valuable. I think that is important to have some trials before we make a super large test dataset, and we can that leads us to a more valuable directions that guide us to build a better benchmarking.
Okay, yes, makes sense. Makes sense to me.
Okay,
I
great.
will integrate it with VNVs when testing with small data sets because uh, that's how I'll understand the matrices and the leaderboard at the end and the report showing what and what at what condition. Accordingly, I make the changes.
Great. And thank you. That looks sounds perfect. Okay. Are there any other comments from our community members? Okay, if not, I think that is also the end of our second topic. And now we passed it to our host.
Okay. Thank you, Ronak, and thank you, Abhishek. So now this is the end of the international session, and we will move on to the Chinese session. And as usual, in Chinese session, we use the Mandarin Chinese to discuss the topics. 好的，那接下来我们进入这个中文议程，然后我们今天只有一个议题，就是武文涵同学的，也只有武文涵同学上线，那我们就跳过前面那个进展同步环节了，就文涵你那边要不直接开始共享屏幕讲一下？
哦，好的好的。哦，可以看到吗？
可以看到。
哦，对，然后我主要就是加了一下，就按之前的那个说法，加了一下代码的一个 README，以及就是一些 PY 文件的一个文件前面的一些信息，对，然后其他的也没有怎么改。然后 PR 的话，我加了一个那个视频，对，就是前面说的那个。哎嗯然后这应该是个演示视频，但是它像素非常低，因为它的那个大小好像特别特别小，因为它这个有要求，对。然后我其他的应该没什么进一步改的了，对。然后目前这里是有一个文件结构和说明，然后一个测试环境，包括一些包，然后一个运行的步骤。您看您那边有什么问题吗？
嗯，你看一下，README 整体还可以吧，然后它的 yes。就是你最好这个 README 这下面再放一个，就是它那个运行结束的一个效果的展示，就是它最后不是会出现一个排
一个表格。
行榜吗？对，你就要
哦
把那排行
哦
榜也放到那个下面，就是说它如果正常运行结束的话，大概会显示是一个什么样子的东西。
哦，好，就是一个排行榜的截图是吗？
对，那个排行榜其实也不用截图，其实它那个东西就你本身就可以复制过去，它就是一种表格形式的。
嗯，好的好的好的，行，那我去改一下。
嗯，对，然后可能就是那个，代码的话，我前段时间比较忙，我可能最近再去看一下你那个代码部分吧。
嗯，好的好的，谢谢老师。
就是就是它那个有一个你可以先去改一下，就是说它那个社区不是有一个那个 Jiminy 给了一些那个代码的建议吗？就是它里面提
哦，对，
到一些，你可以那些我觉得确实也都可以去改一下，就是说像有一些那个编码路径啊啥的，就是你把它最好改成，就不要把它弄成这种硬编码的，就是说你这里面就
哦，好，
有一些是你个人的路径，类似这样的一些问题，
行，
就是
那我把这个部分
说。
先改一下。
对对，就
哦，
是说那个 Gemini 它给你指出来都里
那我
面可以
直接点成这
先，
种点杠就可以是吗？就是一个虚拟的，对。还
对，原则
是说我直接
上来说
不填？
应该弄成点杠的应该就可以。就是说你因为你这个路径下你给一个相对路径的话，应该就也可以找到这个 base model 的这个文件。
好的好的，我把这部分去改一下。
对，就是这些，反正你可以现在先都去，先去再 polish 一下，就这一部分。
好的好的好的。
嗯，他其实就我还想问一下，就是他最终的实验结果是怎么样？就是说他的那个准确率啊或者啥的，有没有一些这个，就是有没有一些能得到一些结论，就是说用哪个算法它的效果比较好呀，或者啥的？
哦，这个我目前还没有去那个，因为我这个跑的可能它的那个数据量也不一定一样，对，我可能后面还要再跑一下，对。
嗯，是，就是说前期已经搭通了之后，我觉得后面就是你可以在，因为本身我们就是做一个这个实现了这样一个大模型联邦微调的一个benchmark 嘛，然后就是可以再丰富一些，就是说去用 Llanos 这个去做一些测试，可能就调一调不同的这个超参呀或者啥的，然后看一下它那个效果，就是说
哦，好的，
对，因
好的，
为前期你不都已经做的差不多了嘛，然后这个可以。就我觉得可以做一些这个，然后也可以放到你那个README 里面，就是你大概去说一下可能不同的，就是它最终的这个效果的话，就有没有什么可以给大家 take away 的这个结论啊啥的，再用这个框架去测试的时候，就比如说什么样的
好的好的
这个超参会效果好一些，类似这样的一些。
好的，那我去完善一下，然后改一下那个 README，对。
对，然后其他就是那个，代码那个就可以先按那个 Jiminy 给的那个建议先去改一下。
好的好的。
嗯，看子木老师那边有没有什么 comment
刚刚我接了个电话，然后不
啊？
过应该大体代码上的应该那个回头时间老师慢慢看一下。然后呢，现在 README 已经 ready 了。
嗯，对，README 它现在基本上 ready 了吧？就看上去还是就有基本的这个教程啊或者使用啥。
OK，嗯，咱的 README 里面，我反正整体的大的那个 tutorial 估计是有，但是我其实一直觉得我们的 README 有个问题，就是其实大家打开来之后，其实有时候除了那个步骤之外，其实他也想知道我们这个项目能干嘛，就是他点进来可能会有点懵，就是当然我们前面可能简单的介绍一下，对吧？就那个有个 overview 这样子，我在想我们是不是也把那个 proposal 的一部分也是不是也可以放进来，就
哦，好，那我在前面加一部分嘛。
对，就是介绍一下，说我们可能不涉及到具体的细节，对吧？就是那个proposal 里头有个 detail design 那个部分，对吧？就那些可能可以往后放，就是，但我觉得它可能其实也值得放到那个 README 里面，然后就是给他们一个是给他们讲说里面具体什么原理这个部分倒是可以往后放一下，那它前面的部分就是包括我们解决什么问题，然后我们 motivation 是什么东西，对吧？然后我们目标是啥，然后对吧？然后大概是给每一个用户都做了些什么事情，就这个是可以在前面稍微给点篇幅，然后他看完
好的，
之后，看完之
好的。
后我看看啊，其他的应该还好。然后呢，文涵这个进展挺好的。然后呢，我觉得，你后面有什么计划吗？
哦，您是说这个项目吗？还是说什么？
对对对对，如果那个待会 README 改完，然后石金老师如果看完代码觉得 OK 对吧？然后你后面有对这个项目本身有没有什么计划？
哦，我本身可能没有进一步的计划，对，因
啊，
为
那行那行，
因为最近可能比较忙，对。
现在那个我们对比了多少种那个联邦学习的模式？
哦，联邦学习的模型指的是。
或者联网学习的算法，对吧？我们这个 benchmark
它本身有，就它本身聚合算法是不一样的，然后它就是它本地的那个 local train 的方法也是不一样的。对，
没有，
就是
我问那个有多少种
组合起来大概有4种嘛。对，就不
？OK，
含超参之类的调整。对，
那我觉得其实也还凑合。然后是不是写个文章出来？就是因为我们就这样那个写完，然后放在这个仓库里面，当然也挺好，只是说那个可能还是需要适当的做一些对外的一些发声，不然的话，大家也不知道我们静悄悄的放了一个这样的一个很好的项目在这，对吧？就比较可惜。所以看看那个文涵是不是你可以把那个 proposal 里面，对吧？就像我刚才说的，一个把背景放到这个 README 的前面，然后第二是有一些实现的上的细节，也可以放到这个 README 的后半部分。然后呢，接下来把这个东西给它转成一个中文，然后呢，我们去社区那边，我给你申请一下，然后在 KubeEdge 的社区公众号上发个文章，然后给大家介绍一下咱这个工作，然后其实觉得反正写都写，然后还是希望那个有更多的那个学者啊或者团队可以把我们的工作用起来。
嗯，好的。
对，其实不会有增加太多工作量，其实本来 README 就是写完那个整体的情况，只是说我们再给个中文版。
嗯，好的，好的。
然后也可以问问那个胡尚老师想法，就是他如果有，比方说实验室有一些什么的，包括文涵自己，如果你有一些什么个人的一些东西想顺便让大家知道，对吧？有一些成果想让大家知道，那社区正好给你们打个广告也没问题。好，就你可以
好的，
一
我问一下
块
胡老师。
放到那个，对，可以一块放到那个文章里面去，尤其是一些
嗯，
跟
好的。
边缘计算、边缘 AI 有关系的那个一些成果，其实是可以通过我们公众号的这个机会顺便也曝个光，我觉得挺好的。
嗯，好的，好的。
好了，目前我这边没有其他。
好的，好，那看文涵那边还有其他问题吗？
我暂时没有了。对，谢谢各位老师。
也谢谢文涵今天过来。
好的。
好，那就我们今天所有议题都结束了，然后也感谢大家来参加我们本次的例会。那我们今天就先到这儿，大家再见，
拜拜。
拜拜。